In this video, we're going to focus on adding nodes to our Elasticsearch cluster. Through this video, we're going to look at the current state of our Elasticsearch cluster in Kibana. We'll see that it's yellow and needs some help. We'll look at some of the configuration items in that node. We'll add a new node. Then why not add another node? Then we'll go back to Kibana and watch as our cluster status goes green. First, let's look at Kibana and find out what the current status of our cluster is. When we get to Kibana, we'll follow the Monitoring tab on the left, and we'll see immediately that our Elasticsearch cluster is yellow. We need to allocate missing replica shards. We'll scroll down and we'll see within our Elasticsearch section of XPack for monitoring, we'll see our nodes. We can click on the node and we can see node 0 is the one we've been using this whole video. It's currently online and it has 54 shards. But again, we see that it's yellow because we know that it's missing replica shards. We can look through some of the data to find the index, and we know that we have 5 unassigned replica shards. So let's go back. We'll leave this screen here. This is showing all the nodes in our cluster. Let's look through the configuration of our first Elasticsearch node. We're going to talk about discovery, the name, and the IP of the node. Here I have an SSH session open with the node that we've been using all along. So if we open etc elasticsearch elasticsearch.yaml, we'll scroll through the configuration items that we've looked at. We have our cluster name defined as packed elastic 6. This is important. We'll need to know this cluster name across all of our nodes. Node name, here we have node 0. We need a unique name for each node as we add them. Here's an interesting setting. We can add attributes for each of these nodes, and these can be used in routing of our data in our shards. But the important ones I want to look at now are our network. So the default network bind IP address is the local host. So since we know we want to do some communications across our network, let's change this to use all of the interfaces that we have available. So I changed it to 0.0.0.0, which is shortcut for all. And here's a section on discovery. We have a couple things blocked out. We have the Zen ping unicast. We have a default that we're going to talk about in a second. And then a neat feature that's not built in. But since we've changed the IP address, let's restart our Elasticsearch node. I always like to clean up my log files so I can see a fresh view. Let's restart Elasticsearch. And let's look at the contents of this log file as it comes out. I'm going to show you what IP addresses we're listening on. Alright, so this cluster is running, and you can see it's back in the yellow status as we expected. I'm going to scroll back up to the top, though, here, and show you a couple of interesting things. So here we see our node name of node 0. This is important to verify our configuration settings. Loading modules, not too worried about that. Now here we have our published IP address. So this is an IP address on my local network that Elasticsearch is using. So you can see Elasticsearch is discovering itself as a master because there's no other nodes in our cluster. 10.0.0.140. That's the IP address of this host. Now I'm actually going to leave this log file tailed, so as we do some things, we'll be able to see it. Now the discovery is how nodes within your cluster or nodes within your networks can find each other. So that's one of the great things about Elasticsearch is out of the box, you can configure a new node, put it on your network, and if you have a multicast enabled network, then the nodes can auto-discover each other and just connect, and as long as they have the same cluster name and a unique node name, then they'll work together and they'll expand your node. If you're in an environment, though, that doesn't allow multicast, such as AWS, you can use unicast, which means you can configure a predefined list of IP addresses or host names that Elasticsearch will use to discover new nodes. Now that's great, but it's a little cumbersome when you're expanding. You got to change your configuration files, etc. And some nodes are temporal, in reality. If a node crashes, you can't recover it, you build a new one, now you got to change your lists. So what they do for AWS, one of the plugins that's available, is a S3 based or discovery option. So your nodes basically register themselves in an S3 bucket. S3 is Amazon's simple storage solution. It's basically a highly backed up, highly redundant network file system where you can put in files and get them later. So the Elasticsearch with this plugin can use S3 to kind of build a file system based registry of the nodes in your cluster. So that's a plugin you have to install if you do want to run in AWS. So now let's add a second node to our cluster. So I happen to have a few created on my network. So let's see the IP address of this second node, 10.0.0.2.10. The first one was 10.0.0.140, I believe. So let's check our Elasticsearch. Let me make sure Elasticsearch is not running. Service Elasticsearch, stop. Let's clean out those log files. Like I said, I like fresh log files. Make sure we don't have any Elastic data, because this is a clone of the original one. So here, let's change our Elasticsearch YAML file again. So we want to make sure we're in the same cluster. Packed Elastic 6 is the cluster we're looking at. And here you can see I've already set up a new node name 1, node 1. I don't use these node attributes for here. And I'm going to get down to this bind IP address. So you can see I've already set the bind IP address to 0.0.0.0. So this should be good. Since I'm on a network that enables multicast, I don't have to do any unicast searching. So let's start Elasticsearch on this one, and then we'll tail that log file. All right, let's go to the top and just watch it as it goes by. So the same kind of things. We've set up some memory, some heap. We have our node name of node 1, loading plugins. Now here we bound to 10.0.0.2.10 like we expected, so that's great. And let's see if it found the other node. Now an interesting thing about my network, since I'm running in VirtualBox, it seems like the broadcast is not working. So what I'm going to do is I'm going to set up the unicast IPs on my node 1. So let's stop Elasticsearch, move our log files, edit our Elasticsearch YAML again. Now here I'm going to go to the discovery unicast hosts, and I'm going to put in the IP address of my master node for now, and we'll start Elasticsearch. Okay, we'll tail our log file again and watch it connect. All right, and since we've started this a few times, we've got a duplicate index name. See, these are the things you kind of work through when you're learning Elasticsearch. And I think you go through as a publisher, because I've ran this a few times, so I have dangling data, and Elasticsearch calls that dangling nodes, or dangling indexes, which means since it's doing monitoring on this node, it already has an index named something that's on the node we're trying to join, so I got to clean up a little bit of data. So we'll find our Elastic data path. Let's just remove all the data it's stored so far. We'll go back and make sure our logs are empty, and they are, and we'll start Elasticsearch one more time. All right, let's watch through here again, make sure we're on the right IP address. It should be down here, yep, 10.0.0.2.10. And let's see, all right. It's starting the node. It detected the master at node 0, like we expected it to. It's applying the cluster state from the master, validating license, and now new local watcher shard allocation IDs. So this node has connected to our cluster, and we've learned a few things. So let's do that in another node. See? Wash, rinse, and repeat. So the lessons learned through that process. Usually you can just do multicast if you're on the same network and broadcast data is allowed. I'm not entirely sure why, but I'm in VirtualBox with these hosts, and for some reason it's not allowing me to multicast, so I'm using the Zen Unicast. And I'm specifying the master node or any other node IP address of my cluster. So let's slide on into the third host, make sure Elasticsearch is stopped. Let's see if we can get this right the first time. Make sure Elastic data is gone. I like removing my log files, although this isn't terribly necessary. And then we'll go look at our Elasticsearch YAML. Where's my name? So this one's going to be node 2. I've already been in here apparently. And we'll go to our network host. We can bind it on 0.0.0. Let's see what our actual IP address is. See, look at that. I'm glad I looked, I need to start my NIC because I didn't have an IP address, but now I will. So here we are, 10.0.0.0.126. So we'll open up Elasticsearch YAML again, and we'll still leave our network host as 0.0.0. That's okay. But here again, remember, we're going to change our discovery Zen unicast host to 10.0.0.140. Get rid of the extra one in here, and we'll see if we join the cluster the first try. And we'll watch our log file. See what happens here. So here we see the node 2 is starting. All of our Java stuff. Publish address of 0.0.126, and again, there we go, first try, detected master node 0. So we have node 0, node 1, and node 2. So if we go back to our first node, this is node 0, you can see a lot of log file stuff came out since our other nodes started joining. So let's see if we can find anything on them joining. So this is one, added node 2. So let's go back to Kibana and see what it looks like. I'm just going to do a hard refresh. Make sure, oops, I'm on the right one. I'm going to do a hard refresh here of our Kibana. And now we're going to see node 0, node 1, and node 2. This is a temporary node 1 when it was dangling, so I killed that one, and it's not going to come back. So now we see that we have 3 nodes. Look, our health is green. We can go to our indexes. We can find today's index. And we have all of our shards assigned. That is pretty slick. Let's see. I want to see history of... Let's see if we can find something. I want to see if it makes sense, if I can find it. Monitoring. Indices. Today. Alright, I was looking for if we could see any sort of history on relocating nodes. That's important because the unassigned replica shards, at one point when the master node decides they need to move from one host to another, they go through a relocating phase. That just means it's copying data from one host to another. Since we saw green as our cluster status, green means go, so we're all happy. All right, next video we're going to talk about a master node and how a master node is different than a data node or a master and data node or an indexing node, etc.